You may remember that when we were discussing the horizon coordinates, altitude and azimuth, one of the big problems that we had was that the sky kept changing. As Earth rotated, then the altitude and azimuth kept changing. And so things would rise in the east and they would set in the west. So this type of motion, due to the Earth's rotation, is called diurnal motion. And it's mainly just the Earth's rotating that's causing this. And so that's what we're going to talk about now is diurnal motion, the daily motion of the sky, or apparent motion of the sky. It's not really the sky moving, it's really Earth rotating, but our view of the sky keeps changing. Diurnal motion is mainly due to the rotation of the Earth. And so you go out at night, look up, and you see certain constellations high overhead, but a few hours later you see different constellations overhead. So it looked to you as if this constellation that was low in the sky had moved to overhead. And so that motion, due to the rotation of the Earth, it's not the stars that are moving, it's Earth rotating, we call diurnal motion. As the Earth rotates, the spot directly over the North Pole of the Earth stays put. That doesn't move. The spot directly over the South Pole stays put. It doesn't move. And so that means that the spot directly over the equator is always over the equator here, the celestial equator. So somewhere along the celestial sphere, on the celestial equator is directly overhead. And so what we discover is, for example, here in the Tarrant County area, we're almost 33 degrees north latitude. So that means if you look straight overhead, the zenith, or the point directly overhead, is 33 degrees north of the celestial equator. Your book has 35 here. I borrowed that slide right from the book. But we're 33 degrees north of the celestial equator. And so that's your zenith, which means the celestial equator is 33 degrees south of overhead. So that means if you go out and you look, then something on the celestial equator would be south of overhead by 33 degrees. Well, from the celestial equator to the north celestial pole is 90 degrees. So it's 33 degrees from the celestial equator to overhead. That means it's only 57 degrees from overhead to the north celestial pole. So that means the North Star is going to be 57 degrees from the zenith. That means it's going to be 33 degrees from the horizon. So that's kind of an interesting thing. Then the north celestial pole is going to be as far above the horizon as your latitude is. So if you're in the northern hemisphere, it's going to be that far above the horizon. If in the southern hemisphere, it's going to be below the horizon. And so stars that are about 5 degrees from the North Star stay 5 degrees from the North Star to make loops in the sky. Well, the North Star is 33 degrees above our horizon, so that means when it's below the North Star, it's still 33 minus 5. That's still going to be 28 degrees from the horizon. It's going to be 38 degrees above the horizon when it's above there. So that means stars make loops in the north. Those stars never rise or set. They just continue to make loops in the northern sky because they never get below the horizon. We call those circumpolar stars. Okay, now conversely, it turns out that stars that are close to the south celestial pole will never get far enough up to come above our horizon. So there's some stars we can never see from Texas because they're too far south. They're always below the horizon. Those we call the south circumpolar stars. The north circumpolar stars never set, and so that's where this comes from. That's one of the questions that's going to be in that planisphere lab is which things never rise, which things never set, and those would be the circumpolar stars. That's a time-lapse photograph at an observatory facing north. North Star barely moves at all. It's technically a tiny bit off the North Celestial Pole, so it does make it move a little bit. But the other stars make these big arcs around there. Now, if we would have had a 24-hour time exposure, then they would have made complete circles around the sky. Now, we're not going to have a 24-hour time exposure because the sun would eventually come up and that would wreck the photograph. In this slide right here, you see the Big Dipper, and the Big Dipper is down here. And one of the interesting things here is that the Big Dipper can be used to find the North Star. This is one of the things we learned in the Boy Scouts, was you find the two N stars in the Big Dipper, and those stars point up here to that star. That star is the North Star. And so the Alpha and Beta Ursa Majoris stars, they're called Dubhe and Merak, and they're known sometimes as the pointer stars because they point to the North Star. So as the sky moves, these stars all rotate around the North Star, and so you can use this to find it, except when the Big Dipper's below the horizon, because that happens if you're this far south. Now, if you're up in the northern part of the country, New England or places like that, then the Big Dipper is always up. It never goes below the horizon. But in the southern states, then the North Star is closer to the horizon, and so the Big Dipper is only partially circumpolar. So Ursa Major is partially circumpolar for us. Which means that it does dip below the horizon, and so that means that it's not usable to find the North Star during part of the year.